Hello everyone. Today we'll talk about the solution to the problem maximum beauty of an array after applying operation. Instead of thinking about operations, this problem asks us to find the longest subsequence such that the maximum and minimum value within that subsequence differ by at most 2 times k. It's easy to see that this is equivalent. And of course it's important to note that we are being asked to find a subsequence and not a subarray. Because finding a subarray is a different problem, feel free to think about it if you want. And when it comes to finding a subsequence, here we don't care about the order of elements in our subsequence, because we only care about their values, the difference between the maximum and minimum, but not about the order, which means that the answer doesn't depend on the order of the subsequence, so it doesn't depend on the order of the original array, and in particular we can sort the original array. Now, what does sorting give us? Of course it costs us the n log n time complexity, but what it gives us is that now our subsequences are the same as subarrays. Because if we want to make it as long as possible, then whenever we have some subsequence, then first of all, if there are any gaps within our subsequence, we can fill them up, because those values within those gaps are between some smaller value and some bigger value. And that means that whenever we have a subsequence that's not a subarray, we can just make a better subsequence that is a subarray. And to now find the longest subarray that has this property, that maximum minus minimum does not exceed 2 times k, in an ordered, sorted array, which just means that the last element minus first element do not exceed 2 times k, well, we can simply use 2 pointers to go through all the elements in our nums, so all the v's in nums, and we compare the leftmost element, for which we have this pointer I, and that leftmost element cannot be smaller than the rightmost element, so our v, minus k and minus k. This is just this 2 times k factor. While that is true, we have to push the left hand forward, and after all this is done, I is pointing to the leftmost value, which is still not smaller than v minus 2 times k. And of course, at every position, since we now see for every ending position j, we find the best I, then j minus I plus 1 is the length of that subarray. We remember it as a possible result, and at the end, of course, we have to return the result. So, very easy. And as I mentioned, if you want to solve this problem, but instead of subsequence, you want to use a subarray, this is a nice exercise for you.